Okay, hi everybody, welcome back. So we're going to be starting a unit on trigonometry. Our first lesson is a review of last year. It's primary trig ratio. So this is where last year we did SOHCAHTOA, if you remember that. Okay, so just a quick review here on getting started with SOHCAHTOA. It's very important that we identify either the required or the given angle. So that's usually inside of my right angle triangle. I'm going to give you an angle that's marked, and I want you to solve for that marked angle, or I'm going to give you an angle and it's going to have the actual degree there. There'll be a number. That angle is very, very important because you have to label your entire triangle based off that angle. And remember, we're not paying attention to that 90 degrees. That 90 degrees is always going to be there and we can't use it. So we're going to find the required angle. In this case, it's angle A. And then we're going to label our triangle based on that angle. So from last year, we said that when we have that angle, across from that angle would be our opposite side. Our hypotenuse is always our diagonal, which is across from my 90 degrees. And adjacent is the side that's attached to the angle, and it's not the hypotenuse. So I think that's the easiest order to be able to label your opposite, hypotenuse, and adjacent, is that you first identify your angle. So let's try it over here. We identify our angle. We label the side across from our angle first, and we label that as opposite. Then we label our hypotenuse, which is across from our 90 degrees, and then we label our adjacent, which is attached to the angle and not the hypotenuse. So that's taking care of this part where we're solving for the opposite, hypotenuse, and adjacent, because all three of our formulas, sine, cos, and tan, have opposite, hypotenuse, and adjacent inside the formula. So without being able to identify those different side lengths, we won't be able to use these formulas. So from last year, sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. Now, for this year, we're going a little bit quicker, right? So we're getting rid of this stuff, which is just practicing turning things into ratios or into degrees. We're going to get right into it. So for my first one here, I've given you the angle 68. So I'm not asking you to solve for that angle, I'm giving you that angle. I'm actually asking you to solve for a side length. The side length that I'm asking you to solve for is y. So the first thing that you're going to do is find the angle, which is that 68. And now we're going to go across from that 68 and we'll label this y as opposite. Across from my 90 degrees is my hypotenuse, and then my adjacent is the last side. Now, every formula only has two different side lengths. So we've got to get rid of one of these side lengths. It's useless to me. I don't need it. It doesn't give me any information. Side length A is that side length that I'm going to get rid of. It's useless. It provides me with nothing. I don't need it. It doesn't give me a number there. So now I'm going to look at the letters that I have left. I have an O and an H. So now I'm going to go to the formula that has an O and an H in it, which, going back up to the top here, we can see that O and H is sine. So I'm going to be using the sine formula. So we'll come down here, sine theta, and remember theta just means angle. So sine theta is opposite over hypotenuse. And now we'll start replacing with what we know. You know that your angle, theta, is 68. You know that your opposite is the letter y, and that your hypotenuse is 15. Now the way that we solved this last year is that we use cross multiplication. So we put that sine 68 over 1, because sine 68 divided by 1 is still sine 68, and then we began to cross multiply. 1 times y is y. Sine 68 times 15 is sine 68 times 15. Now on your calculator, you would simply write in sine 68 press equal if you need to, if you don't have a two-line calculator. So find out what sine 68 is, and then multiply it by 15. And you should get a side length of 14. If you're not getting that side length of 14, it's most likely because your calculator is in another mode aside from degree. So you have to look at the top of your calculator and make sure that there's a DEG there or a D. If you see any other letter at the top of your screen there, if you see an R or a G, that means you're in radians and gradients. So you won't be getting the correct answer. So you're going to have to find a way of clearing your calculator and resetting it so that it has D or DEG at the top. Now let's practice another one here of solving for side lengths. You find your angle, you label your triangle based off that angle, O, we'll put in our H and our A, then we'll eliminate a letter. In this case we're eliminating H, it's useless, doesn't provide me with any information, I don't need it. I need the O, I have the O and I need the A. Then you'll look at your formulas, which one has O and A, which is tan. So tan theta is opposite over adjacent. Then you'll fill it in, tan theta, theta being the angle, which is 40, opposite being 10, adjacent being M in this case. We'll cross multiply, 1 times 10 is 10, tan 40 times M is tan 40M. And look, we've done the exact same thing that we've done over here. The sine 68 times 15, tan 40 times M. But now, can I type that into my calculator? Can I type in tan 40 times M and get an answer? No, I can't. So M is my variable. And right now I've got a tan 40 in front of that M. So that's like saying, I'm going to go up here and just show you what that's like. On the other side I have a 10. And now I've got this tan M. And I'm going to put a number there. Instead of tan 40, I'm going to write the number 2. Because tan 40 is just a number. If I type in tan 40 on my calculator right now, tan 40, I can see what the number is. It's 0.839. It's a terrible number. So I'm going to write the number 2 to pretend. How would I have gotten rid of this 2 in front of this M in algebra? That's right, opposite operations. 2 times M, the opposite of multiplying is dividing. So to get rid of that 2, I would divide by both sides, and then 10 divided by 2 is 5, and that's what M is. So instead of dividing by 2, I'm going to divide by the number. So I'm going to come back down here, and I'm going to divide by the number. But I'm not going to write down 0.839099631. That's a terrible number. The number is tan 40. And that'll get rid of it. And I'll be left with an M. But what I do on the right side, I also have to do on the left side. So now we're going to take our calculator, and we'll do 10 divided by tan 40. And we'll get 11.9, so I'm going to round that to 12. Now these are the 2 different ways that you can use SOHCAHTOA for solving for your side length. And what I mean by that is either the variable is going to be on the top or the variable is going to be on the bottom. Okay? So now it's just a matter of you practicing whether the variable is on the top or choosing the right equation. From SOHCAHTOA, which one am I dealing with? Sine, cos, or tan? Now is the variable on the top or is it on the bottom? If it's on the top, great, it's easy. Multiply them and you're done. If it's on the bottom, cool. Multiply them, then divide. Now I want you to practice the rest for C and then check your solution inside of the filled in version that I've given you on Google Classroom. Now I want to do a quick review of how you solve for an angle. So this is a little bit easier. When we need to solve for an angle, a marked angle, the only thing that you need to remember from last year is that you need to press that shift or that second function button on your calculator because you have to use the inverse. So if you look at your calculator, above your sine, cos, and tan button, you should see sine to the power of -1, cos to the power of -1, and tan to the power of -1. These are the buttons that you need to use or activate in order to solve for an angle. So let's look at that now. We need this angle, W. Of course, that's the marked angle or the given angle. So we're going to label our triangle based off that angle. Opposite is across from it. H is opposite of my 90 degrees. That leaves me with A. Same process as before. Let's get rid of a letter that offers us no information that we don't need to know. H gives me 18. A gives me 15. O gives me nothing. Goodbye, O. Don't need you. A and H. Now look at your formulas and which one has A and H in it. Cos. So cos theta is adjacent over hypotenuse. Now, you don't know what the cos theta is. So you're trying to find out that angle. So I can't fill it in with some angle that I don't know. I have to fill in what I know. And all I know is that A is a 15 and H is 18. And now we're going to activate that cos second function button on our calculator. So let's press that shift or that second function, then press cos. And then I want you to, in brackets, use brackets, 15 divided by 18, put a bracket, and press equal. And you should get the answer 33 degrees. Now, if you can't get that because you don't have a two-line calculator, then you're going to have to do 15 divided by 18 first and get 0.83. Once you get that 0.83, you're going to press shift or that second function button, cos, press equal, and then it should turn that 0.83 into a 33 degrees. Now I'll do one more example with you, but it's the exact same thing. You find your angle, there it is, label your triangle O, H, and A, get rid of a letter, this case H, unnecessary, O and A, which is going back to tan. We'll label it O and A for our formula, and then we'll replace it with 9 over 10, and then we'll do the exact same thing again. So shift, 10, bracket, 9 divided by 10, bracket, and you should get 41.9 degrees or 42 degrees. Again, if you have a one-line calculator, you're going to need to have to find that decimal first. So 9 divided by 10, which is 0.9, then shift tan that 0.9 and to be able to get that 42 degrees on that that one-line calculator. Again, you're going to practice C on your own. There's nothing new with it here. You just label the same triangle again and then choose the right formula. Okay, we're going to practice the next example here where we're basically solving for multiple angles and for a different one or two side lengths. So let's look at what we've got here. Question 6a, find the measure of side Q to the nearest tenth of a meter. So right now, if it's asking me for side Q, it's a right angle triangle. It's not giving me any angles though. I can see that right now. It's kind of weird, isn't it? So I've got to think back. How can I solve for a missing side length given two other side lengths in a right angle triangle? That's right. You can use Pythagorean theory. So for this example here, I could simply use c squared is equal to a squared plus b squared. And then I'll just write in the other two side lengths to be able to solve for my hypotenuse. I'll use my calculator. 8 squared plus 5 squared is 89. We'll square root that 89 and find out that that side length is 9.4. Cool. If you don't want to use Pythagorean theory, guess what? You don't have to anymore. So we're going to find out that 9.4 using a different method. We're going to find it using SOHCAHTOA. But in order to use SOHCAHTOA, I can't do A, B, C in the order that it's given to me. I'm going to have to do it a little bit out of order because I need a angle first. So how about we solve for eeny, meeny, miny, mo, catch a tiger by the toe. Let's solve for angle P first. Okay? So to solve for angle P, we're going to label our triangle based off of angle P. So O, H, and A. We'll get rid of the letter that provides me no information at all. Remember, I don't know that Q yet. I don't know what it is. I've solved that it's 9.4 using Pythagorean theory, but I don't want to use Pythagorean theory, so I'm using a different method here. So let's get rid of H, and let's use O and A, which is going to be tan again. So tan of an angle, I don't know what that angle is, O divided by A. Let's fill it in with what we know. We know our O is 5, our A is 8. Let's use our second function button. So let's use that shift tan, 5 divided by 8 in brackets, and we'll find out that that angle is 32 degrees. Cool. Now that I know that angle is 32 degrees, I can use that O or that A to solve for H. So which one do you want to use? Do you want to use the O or do you want to use the A? Using the O, I would use sine. Using the A, I would use cosine. So maybe I would use sine. We like sine. So sine of 32 degrees is equal to 5 over H. Now, this is where the variable is on the bottom, so it's going to involve multiplying and then dividing. So 1 times 5 is 5. Sine 32 times H is sine 32 times H. Then we'll divide by sine 32. And guess what? On our calculators, if we did 5 divided by sine 32, don't use inverse, just use regular sine. What answer does it give you? That's right, 9.4 for my hypotenuse, which is the same answer that I got over here using Pythagorean theory. Now, I can go through the work of using SOHCAHTOA again to solve for that missing angle R, but I don't think I need to. I know that inside of any triangle, the total is 180. And right now, I found that there's a 90-degree angle in there and a 32-degree angle. So if I subtract 90 and 32 from 180, I can find out that the missing angle, angle R, is 58 degrees. So this is a culminating example of how to go about thinking or breaking down a triangle into solving for either angles or side lengths. And I just want to show you my thought process of the different methods that I can use, either Pythagorean theory or, you know what, let's solve for an angle first, then we'll solve for our side lengths, because I know that in order to solve for a side length, I first need an angle for SOHCAHTOA to work, right? So if you look here for SOHCAHTOA, this part, to be able to solve for a side length, I needed that angle 32. Could I have used this other angle? Sure. It would have been the same answer. It just means that I needed to label the triangle a little bit differently. This would have had to have been my O. This would have been my A. And then I would have to use different formulas based off that. So trig is a very kind of fun unit in that you get to decide how you want to solve these triangles and what formulas you want to use. Now, for the rest of this, for 7 there, I want you to be able to try that on your own and then check your solutions in the filled-in version. I'm concerned about you being able to solve for a triangle on your own, like the one that we have in example number 6 here. Okay? So that's where primary trig ratios is going to end. The rest of the lesson for SOHCAHTOA is dealing with word problems. And right now, because we're at the end of the year here, and we're just covering all overall expectations at this point, the expectation for trigonometry is to be able to use primary trig ratios, which is SOHCAHTOA. So we're not going to be doing these word problems, for SOHCAHTOA for primary trig ratios, because you already did that last year. It's going to be more important for us to do sine law and cosine law word problems, which are the next 2 lessons. So right now, for trigonometry for primary trig ratios,